Hi everyone, welcome to my part 2 presentation on debugging the Linux kernel. Today we're going to get Syzkaller up and running and fuzzing a custom kernel on Fedora 32 running under QEMU or on top of QEMU, however you want to state it. So not the agenda. So today's video is going to be off the cuff. I previously did this setup last week prior to making part 1 of debugging the kernel, where we set up the Fedora Workstation Machine to be able to run our custom kernel. However, there's a lot of things that I've forgotten since then. I've also, because of the problems I was having on my NUC last week, I've decided to switch my, my recording machine to my old gaming machine. That was just collecting dust set up next to my TV that I very rarely use because I'm not a big gamer. So today we have to do everything from scratch. And like I said, I did this last weekend, so there's going to be a few things that I've forgotten. But I thought that you might enjoy seeing me go through the process, making the mistakes so that you can see what mistakes that you might run into when you do this on your own. But please bear with me. This is going to be a lot of debugging rather than just doing things. So hopefully what we will accomplish today is in the Fedora desktop virtual machine, we're going to set it up such that we can SSH into it without providing a password by using a public-private key pair. And we need to be able to do this as root, because Syzkaller needs to be able to SSH in as the root user. After that, we're going to install Go and install Syzkaller, and then we'll set up Syzkaller's configuration file and get Syzkaller up and running. And hopefully, I'll leave it for a few hours, and hopefully it will find a bug. So that's all I've got in terms of slides today. Everything else is going to be bubbling along on the keyboard and in the console. And let's just get to it. So the first thing that we have to do is set up a public-private key pair. So I've already set it up here, but I'm going to do it again for you guys so you can see how I did that. So what you do is SSH keygen. And then you want to call it here.root ID RSA. And there will be no passphrase, so we've got the keys. There's the private key and there's the public key. Now the next thing that we want to do is get that virtual machine up and running. So let's get that machine going using this script, and we will provide our own kernel with our own initd and setup. So we're up and running, and I'm just going to use the command prompt in this top window here. Now the first thing that we have to do is we have to make sure that root can get into SSH. Period. So as default, SSH is will not allow you to log in as root. So you have to do some edits to make sure that you're allowed to do that. And in order to do that, what you want to do is you want to, first of all, get your root user to have a password. So pass wd and then enter your new password. And then what you'll do is you will edit the, you will create a file called etc ssh dconfig, and the file that you should create, sshDconfig.d, and then a file that you can create is called allow root. Now you can call this whatever you want, .conf. What I called it is allowroot.conf. So there's allowroot, and all it does is says permit root login yes. So, and then what you want to do is system control restart SSHD. System control, please. System control restart SSHD. All right. So now we should be able to SSH into root at localhost. And we're in. Okay, so we can log in as root. The thing is, we have to make sure that we don't need to provide a password, because Syzkaller it doesn't have the method of entering the password in its scripts. So the way that we do that is in here. We want to SSH copy the -i, the public private key pair, and I believe, let's just say it's public. No, let's leave it as it is. And then the port is 2222, and the host is, I think it's -h, but if it's not, we'll find out in a second. Root at localhost. No, it's not that. You don't give the -h. All right. All right, so let's test it out. SSH-p 1234 root at localhost. Oh, still needs a password. So why did it not like that? It didn't seem to take that. Okay, maybe it wants the hub. Why is it wanting the password? I'm going to pause the video and figure out what's going on, and I will be right back. All right, so the problem was I screwed up in two ways. First of all, you need to, in that configuration file, you need to allow this pub key authentication yes. So let's go into that configuration file that we created, allow root.conf, and let's allow public key authentication as yes. And then we will system control restart SSHD. And then the next thing that I forgot to do was you have to use this -i and then the key that you're going to be using. So now we've got root login using the public private key pair rather than using a password. So that's the first thing that you have to do. All right, the next thing that we have to do, according to my slides, and this is just going from memory of what I did last week, is you have to install Go and install Syzkaller. Now, how do I know that? I know that because I did a Google for Syzkaller, and I went to their GitHub page, and I scrolled down and I went to how to install Syzkaller. And then I went to the Linux instructions, and then the Ubuntu. Now I'm on Pop! OS, but Pop! OS is basically Ubuntu, so I went to the Ubuntu host. And then I didn't worry about this stuff because that's just getting your toolchain set up. What we want to go to is the Syzkaller stuff, and we have to build Syzkaller as described here. So, first of all, I believe that Pop! OS ships with Go version greater than 1.13. So rather than downloading the wget1, I'm going to allow Pop! OS to give me the Go compiler. So let's do a sudo apt search golang, and golang is here. We don't want the source, we just want golang go. Oh gosh, there's a lot of golang here. Golang go. Golang go is 313. So that's good enough for Syzkaller. So let's sudo apt install golang go. Allow that to run. And then we do this go get-u-d command. Okay. All right, now I believe that put that somewhere in my home folder. So let's open up a new tab. Go into home, and there should be some Go stuff. So there's Go. So cd Go, source, GitHub, Google, Syzkaller. And we want to make this. Now it says make, but I'm going to make it with a whole bunch of cores. All right, we've got the Syzkaller up, and we've got a bin directory at least. So what's in this bin directory? Bin directory's got this a bunch of, it's got a size manager, stuff like that. Now I believe there's a few other tools that we might need, not to run size manager, not to run Syzkaller, but afterwards to be able to reproduce any bugs that it finds. But we'll get to that part when we get to that part. So the next thing I'm going to do is, rather than having all this stuff, well, yeah, okay. So I am going to edit my bash.profile, my bash.rc, to add this directory into the path. Let's move that over there so we can see things. So I'm going to say that path is equal to path colon here. Save that. And let's exit this and then start up a new tab and see if we can get Syzkaller stuff. So we do have it in the bin. Why do I not? Ah, there we go. I was just spelling it wrong. All right, we've got all the tools in our path now. All right, so we've installed it. What is the next thing that we need to do? We need to do the VM setup. Okay. Needs KVM. Yes, we know that. Okay, so we need to set up a configuration file. So, is this configuration file good enough for us? Let's see. So I will copy that, and I will say, let's start up a file called syzfed.conf. And we'll paste that in there, and then we'll change a few of these things here. Our workdir will not be that path. It will be where we run this from .workdir. The kernel object will be code kernel kerndev Linux. Our image is code kerndev /Fedora desktop /Fedora.image. Our SSH key is what was our key called again? Our key was called root ID RSA, so we will copy that, put it in here. Just in case it needs the full path to Syzkaller for some reason. /go source GitHub. Yep. Okay, we will say that we get 2 procs. We'll do 4 machines, and our kernel is /code kern dev Linux. All right. Well, I'm sure that I'm missing something, and in fact, I'm not going to say that. I'm going to say that this goes into /code kern dev workdir. Let's call it Syzkaller workdir, which means I need to make a Syzkaller workdir. Actually, let's put it into the Fedora area too. Fedora desktop. So make sure that I spelled it right there. Okay. All right. So let's hope that it tells me what I did wrong as we run size manager. Right, so this doesn't have that. And that's our virtual machine. So let's run size manager, and then -config equals size fed. Okay, size manager config equals size fed.conf. Can't find the image file. Probably because it is attempting to run this as root, maybe? No, it's not attempting to run as root here. Is that a valid directory? Yes, it's a valid file. Okay, well, let's just hard code them in. So wherever I have a tilde, I want to change that to home Masmullen slash. No, I don't need a slash. Replace all. Try that again. Right, so it doesn't like it that we're already running Fedora here. So let's close up, let's cancel this and close this down. All right, and let's exit out of that window because we don't have the newest bash RC in it, and open up a new one. All right, let's give this a try again. And we have a kernel panic, and that is because it can't get the init.rd. Okay, and it doesn't have the proper the root file system isn't properly set up inside of this. So we're going to have to figure out how to, first of all, pass init.rd into Syzkaller, and then we have to figure out how to give command line options to the kernel command line in Syzkaller. So how do I do that? I think I can put init rd in here and pass the full init rd slash Fedora desktop slash init ramfs.image. And let's see if we get a little bit farther into the boot process. This should still not work properly, but I should at least, yeah, okay, so we're starting up the init.rd. Yes, we got to where we expect. Okay, so how do I get the command line into Syzkaller? How do I add a command line into Syzkaller? Maybe I just put... do I just put command line? Let's try just putting command line. And where is that information about? Let's see, our run script's got that information. This is what we want to add. Let's see if that goes. Give that a try. All right, here we go. Switch root. Looks like it's going. Ran all our SE Linux scripts that Fedora gives us. All right, it seems to be running. Now we're running as debug, which is not what we want, but let's just see if we can get to Syzkaller has a kind of a work screen that you can get through a browser. So at this port, let's go to localhost and see what's there. Local, not sure if it's HTTP or HTTPS. Let's try HTTP first. Local host. All right, Syzkaller is going. So it's only running one virtual machine at the moment, and we want it to run lots more virtual machines because what Syzkaller does is it's a fuzzer that just kind of keeps going forever and finds as many bugs as it can. And when you're kind of sick of it trying to find bugs, then you come over and you Control-C this. So we said that each VM will have 2 processes, and that let's give this a try. Let's oh no, we'll give it a run. So we should have 4 machines with 2 processes each. So hopefully this gets up and running. So it gives us a little kind of a description of what it's going to do here. It's not going to do anything on this namespace sandboxing. Now I'm not sure of all the intricacies of Syzkaller. The reason why I'm setting this up and doing a video on it is simply because I want to learn more about it, and I don't feel as though you can learn about the system without running the system. So this is my newbie starting guide, and I'm just as newbie as you guys about this, with the exception that I've run it once last weekend. So yeah, this is my twice ever run. But it seems that we are up and running, and that it is executing stuff and trying to crash the virtual machines. So maybe I should give it more than 4 systems here. Maybe I should give it how taxing is my desktop right now? Not very taxed at all. Let's take a look at how much QEMU I have. Oh, there's quite a lot of QEMUs. Okay. Should I give them more than 2? Well, it's got 24 QEMUs running. Strange that this goes. Strange that we have that. But they are up and running, and Syzkaller is not complaining. I am going to try and tax my CPU a little bit more than this. So let's actually quit this. And first of all, let's check, did it find any crashes? So inside of kernel dev, Fedora desktop, Syzkaller workdir. Are there any crashes? No, there's no crashes. So didn't find anything in the limited amount of time that we gave it, but it usually, you have to let it run for, so last weekend I let it run for 16 hours, and I think it found one instance of a bug which it hit 20 times, and 4 other instances which it only found once for each of those 4 things in the entire time it was running for those 16 hours. But yeah, let's give it more. Let's see what happens here when I give it more than a count of 4. Let's give it a count of 8. See what happens. And refresh here. Of course, we're not going to see anything yet because it's setting up those virtual machines. pt2 show for QEMU. Not a lot yet, but let it go, let it go. It is taxing our system more. I wish I knew what that entry meant. I thought it was supposed to be how many virtual machines you gave it, but obviously we've got a whole whack of machines here. Oh, okay, okay. Two, 3, 4, 5, 6, 7, 8. Okay. So it is running 8 virtual machines now, and these are simply threads inside of it. That makes more sense to me. So all these are just runner threads for QEMU. That's interesting. Okay, well, cool. Our virtual machines are up and running, and we are attempting to find bugs. So what I'm going to do is I'm going to leave this run for several hours, and hopefully it will find a bug. If it finds a bug, I will come back, and I will show you how you can go about trying to reproduce that bug with a very limited C program. So one of the things that Syzkaller does is it allows you to run a command called syzrepro. So syzrepro will do a bunch of work to reproduce a crash that it finds, and then create C code for you to compile yourself, put on a virtual machine running the kernel that is under test, and that will cause a problem in that kernel. So to be able to reproduce a bug, it gives you this syzrepro to be able to do that. But first we have to find a bug. So I'm going to let this run for a few hours, and I will come back after taking the dog for a walk and having a shower. So talk to you guys in a bit. Welcome back, everyone. So I went for my walk. I hopped in the shower because it's like 32 degrees centigrade outside, and got nice and sweaty from the walk. And after I got out of the shower, I found this. I found that Syzkaller has found us our first bug. So let's just refresh this page. We've been going for an hour and 53 minutes. And this occurred about an hour and a half after we started Syzkaller. And we found our first kernel panic. So on that Syzkaller website that it hosts, we can kind of drill into this error a bit. And the report shows us exactly what the kernel panic was. So it looks like there's something wrong with fixupbad.iret, which is on traps.c line 680. So let's see if we can open that file up, take a look at it. So Linux Arch x86 kernel traps.c, and we want to go to line 680. So it looks like there's something specifically wrong right at the start of this function. And it seems to be called by entry 64s. So let's see if we can open that up. And that's on line 946. So there's something wrong here. Something bad. This is a little bit deeper than I'm comfortable working in, but something bad happened here. So the first thing that we want to do now that we found the bug is to try and get a C program that will reproduce it. Syzkaller will help us with that. How will Syzkaller help us with that? Well, let's see if we can do it. First, I'm going to stop the coverage execution from happening. So this will, when you stop Syzkaller Manager, it's going to make access to this website inaccessible. But luckily, there is all the information is kept inside of that workdir that we saved, and the crash in question is right here. Let's open this with Sublime Text. So this is what Syzkaller did to find that bug. And we can use this log to try and get Syzkaller to make us a reproducible C program. So I'm going to quit Syzkaller. And as you see now, we no longer have access to that website because the manager, the thing running the website is gone. But we do have the bug inside of our file system. So the first thing that we want to do is go over to Syzkaller's GitHub. So let's go to Syzkaller's GitHub. And then let's go down to docs for the documentation and check out their README on reproducing crashes. Now what they say is that there is a program called execproj, which will help in reproducing this bug, and there is something called Syzrepo, which will help doing this, along with Syzprog2c. So first of all, let's go into our Syzkaller directory and check out the bin to see if we've got these programs. And we do not have execproj. We don't have that unless it's in the Linux. All right, we do have execproj. Do we have prog2c? We do have prog2c, and there is Syzrepo. So it looks like we do have these applications available to us. Let's put this Linux AMD 64 inside of our path so that things can find the binaries within it. So again, we will, I think I still have my bash RC up. So we will take this and put it there. All right, okay. So let's close down this window, open a new one, and close down the old window. So now that we have the new, we have a fresh bash RC. And let's just check out that we do have the path. And we have the Linux AMD 64 inside our path now. Okay, so let's CD into the Fedora desktop area, and let's do a Syzrepro using the config that we used before. And it looks like there's no equal sign in this one, it's just a space. So it's Syzfed, and then the log of the crash. So that was in Syzkaller workdir crashes 7.1 and log 0. So let's hope something can come from this. And let it do its thing. It will take a little while to do its thing here, so bear with me. In fact, I'm going to pause the video because I believe this is going to take about 5 minutes. So it's been about 4 minutes, and the ending result of running that Syzrepo is that it spit out a C program on the command prompt for us. So what we're going to do is we are going to copy paste that into an editor. And then we shall save it as crash.c. Okay, and there it is. Let's compile it up. All right, no problems. And we'll start a virtual machine. With our kernel and the necessary stuff, and we won't give it a desktop this time. And I am going to secure copy crash onto localhost and make sure I use my user. All right, we have to do it this way. Why do I not have SSH? And we've got it on the system now. So let's give it a run. Oh, nothing's crashing. What's going on? It's not working. Well, something that Syzkaller doesn't tell you here is that in order to get this to work, to get this C program to reproduce, you have to compile with -O2. Re-upload it. I should really cut down on a lot of these system control things that start up because it's taking my boot process a little bit longer, and when you're reproducing system-wide crashes, you're going to be restarting your virtual machines quite often. All right, now let's give it a try. We crashed it. So what we have done, we have successfully reproduced a bug in the Linux kernel. So what we did is we set up our virtual machine so that root could log into SSH without a password by just using public-private key pair. We set up Syzkaller to be able to run on our virtual machine. Syzkaller then found a bug, which we used Syz repo to get C source code that allowed us to reproduce the bug. So the last step that we want to do is let's look up this bug, because someone might have already looked at this. So, on Friday, May the 29th, it looks like Syzbot itself, which is probably an automated system running for the Linux kernel, found a similar bug to this. And it's on traps 665 for fix up bad IRET. So they probably found this on, they did find this on an earlier version of the 5.7 kernel. So I am running on the latest stable kernel on, but it's the same bug. It's fix up bad IRET. It comes from entry 64. The source code is a little bit different because we're using different versions here. But if we follow up from Dmitry Yukov, he reports saying from the producer, it seems to be either x86 related or ptrace related. And this is saying that it's to do with KSAN bad fix-up. He's going to verify it. So he's saying that this bug is with the KSAN turned on, which is one of the debugging features that we did. We turned on KSAN in order to find bugs. But what he's saying is that we're going to be fixing this later. Right now, we need to exclude this from KSAN or any other magic function. And I'm not sure what he means by magic function, but basically what he's saying is that this is a known bug. What we found out is that this is a known bug, and that they're going to be fixing it up later, but they haven't gotten around to it in the latest stable kernel. And he's saying that one of the things is that this is not reproducible with KSAN off. So that's why this fellow here, Thomas Gliexner, sorry if I'm pronouncing his name incorrectly, is saying that it's not a showstopper bug, but something needs to be done about it soon. So, we have found a bug. Unfortunately or fortunately, it has already been found before by someone else. But we were able to use Syzkaller to find a bug. We were able to reproduce that bug. So we're on our way to understanding how to use this very powerful tool, Syzkaller, in order to help us learn more about the Linux kernel. So in part number 3, we're going to dive into GDB to see if we can learn anything about this bug by using GDB to be able to use breakpoints and stop the kernel and look at things like you are using GDB, but on the kernel. So stay tuned to the next episode, and thank you for watching. I hope you have learned something about Linux, about Syzkaller, and I bid you a good afternoon, good evening, or good day.